So we talk about factors that determine selection of the type of dam and even its location. Uh, just in a nutshell, you need okay. Whenever it is decided to construct a dam, the first question that one is faced with, or that one faces, the first question that one faces is which type of dam will be most suitable and most economical. And then to answer that question, you I think this should be faces. So to answer the question, these are the possible answers. So topography, it dictates the first choice of the type of dam. A narrow U-shaped valley with a narrow stream flowing between high rocks should suggest an overflow dam. So if for example you have mountainous there is a nice and these are kind of, so, and then there are streams flowing somewhere. Let me use different pens here. Streams flowing there from the mountain now, and this is downstream. You are coming downstream, so probably this place we are only talking about the topography because probably between the hills, if you impound water here, so it this can form a very good place of reservoir. And then we are talking about overflow reservoir because maybe just impound enough water. So if water is flowing there, just you can just impound enough, but still the once the water is full here, it can still overflow over the it can still overflow over the barrier or the dam. That's what we are saying. So, but the important thing here is the topography, because you are looking for somewhere that you can easily impound water and is confined, and also you need a space because of course once you impound the water is gonna form something like a lake, and you need space, because if there's no space, it might you don't want your dam structure to interfere, the lake formed behind the dam to interfere with other people, if there are people living around. Then a low-lying plain country would suggest earth dam, uh, an earth dam with separate spillways. Then we are saying a narrow V-shaped valley indicates the choice of an arch dam. So different topography suggests different kinds of dams. This is what we are saying. But that's not all. Once you find the topography is good, because you remember I have said, I think the first example I gave is that once you put the dam, if this is the structure that is going to impound the water, so this is the cross section, you still need to be concerned about the status of the foundation, because of course water would want to escape. uh, there's nothing that is, water will always tend to escape because there's a head here. I think from hydraulics, this is why you should have learned hydraulics. There's a head that will be driving water to this side. So there will be some water, and it's difficult to avoid that. So under the dam, but you need to control the seepage. Even though we know that's gonna happen, we need to control the seepage actually to very, very low levels. Otherwise, the dam will be uh, in jeopardy. So that's the first thing. So this is in case of, that's why in the syllabus we talked about seepage through the foundation, but we can also have, especially for for earth dams, water will also tend to flow through the earth dam. So again, you will have to construct flow nets like this. And you also can estimate seepage through. So this is through the dam. This is through the dam. So it's not enough to have good topography to for dam construction. Once you have good topography, you have to confirm the foundation. Of course, another factor that you must consider is also the availability of the material, even to put this impounding structure. But so far, so we talk about topography. Now the foundation, because you have seen that water can actually seep through the foundation, and you need to control that. Otherwise, the erosion will occur, and if uh, the seepage is not controlled, you might have not have your dam anymore. I don't know any of you, most of you can remember. I think in the previous 3 or 4 years or five, I don't know, there was a dam in Nakuru that collapsed, and that is basically because water was passing through the structure at uncontrolled rates. Eventually, erosion kicked in, and then water could not be controlled, and people lost lives. So this is the point. So you must control the seepage, you must control the erosion, and you also have to check. So sometimes, not even sometimes, most of the time, you do very detailed site investigations, because you can imagine if 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 a dam fails, then the entire city that is downstream, or people living downstream, of course, are probably most likely going to die. So this is why you need to be very careful, and often you have to, when you're doing this the site investigation, you have to map any kind of fault to the detail, and you need to know how many faults, how many lines of weakness do we have under the foundation. So the width of the dam should be minimum, so as to keep the length of the dam minimum, that's economical. So this is, we are still talking about the influence of the dam on the surrounding area. If people are living, you want the depth, I mean the width, to be minimal, such that it doesn't affect other people around the dam. And then, in order to provide large basin of reservoir, the site should be open upstream. I've said this because once you impound, if this is your impounding structure, uh, a lake kind of, this is the plan. So you have water over a large area, and it actually can span kilometers. Maybe this actually sometimes. Uh, Let me use a typical example. This could even be 35 kilometers. So there will be some kind of lake, uh, and the length also will as well span maybe some kilometers, maybe 50. So because then you need space. This is what you are saying. A large basin, you need space, because if there is no space, then when you impound the water, it will affect the people living nearby the site. This is repeated. So uh, when the river is deep but there is raised bed level existing, the dam should be preferably located on the raised bed, at the raised bed. This will help in keeping height of the dam less, in such a situation. A proper separate site for location of spillways should be available. Spillways are kind of breathing, in quotes, breathing routes. They allow if there's too much water, then they allow the water to escape safely. Because a dam has a fixed capacity. Once the capacity is filled, especially during rain, then the spillways allows the dam to breathe, in quotes. It allows excess water to flow away. But then you also need to have the space uh, to build your spillway. Now, if separate spillway site is not available, the width of the dam river should be sufficient to locate spillway in the dam proper. So a spillway is part and parcel of the dam structure or dam morphology. You must provide space to build it, and if there is no such space, then we are saying the width of the river has to be wide enough to allow the construction of spillway. The construction of the dam material should be available. I have said this. If you're talking about earth dam or the concrete dam, all these things have to be, the material has to be availed. Then we are saying very costly land should be avoided, because these are often community projects. You're trying to because the dam will provide probably hydroelectricity, and or as a subsidiary or complementary function, it will provide water to the surrounding areas. If the water is processed, it could even be used as uh, as drinking water if it's treated well. Actually, it's even in the dams, sometimes there are fish, but you are not allowed to fish. Maybe it's a source of water and and electricity. But we are saying not costly land should be used, because you are going to submerge. If the land has good value, but if you submerge it underwater, then it's no longer it will no longer serve any value, any meaningful value. So you need to, because that has also something to do with the economy. For valuable land, probably putting a dam, you need add. I'm tempted to say wasteland, but not so much wasteland, because still, like I've said, the foundation needs to be treated well. So there has to be a balance, but you need to avoid costly land, because costly land, if submerged underwater, will not give us any value, or yeah. And then this is what I was saying. This is like a plan. I'm sure you know this from geography. If you've seen topographical maps here, these are what are they called? I saw these lines show areas of the same height, and these are around mountains, of obviously. And I've said, if the topography, so you can see this is a mountain, this is also a mountain, and then a river there. You put a dam, and this mountain helps you to contain this mountain on this side, and that side helps you to contain the water here, and hopefully there is enough space behind as well, and you have your dam. Another scenario could be, this is, you can see a hill here or a mountain here, mountain there, the rivers there, river. So when you impound here, it's very good because the shape of the you can imagine if you are looking at this in 3D, then it could be, this would be something like a V, I believe a V, or a U, depending on how you look at it. And this is what we have said here, that the location of the dam, uh, we like either U shape or V shape, and whether it's U or V, it determines unique kind of dam that you will have to put up. And again here, there has to be space. Once you impound the water, there has to be space upon which the water will collect itself. And these are mountainous regions, so hopefully there are no people living around. So this dam project will have minimal effect to the uh, people around. So we are saying also the site should be well connected, either railway or highway or both. We're talking about transportation because you will need, if it's cement, of course, if it's cement, if the machinery to work on the site, the borrow pit material, for example, will need to be transported to the site. So the railway and what have you will facilitate transport of cement machinery and other materials required for in the construction. The site should be such that leakage through its sides and bed is minimum. I think I've already said that. Of course, the is is impossible to prevent the leakage. However, need to make it minimum, such that it doesn't go to erosion, and then the dam will be swept away. Highly permeable rock should be absent from the site, and I've said this because the highly permeable rock will lead to high escape water, because uh, there's a head here. The example I already gave here. If there's your dam and you have impounded water here, okay, let's say you have impounded water that way, and this height is depends on the this height is usually very high, maybe 30. Even some dams could be 240 something. You can calculate uh, the pressure. These are the driving head. So the driving head. So that means this water is in a hurry to escape to this side. So that driving head, uh, that means this dam has to be, or the impounding structure has to be designed properly, and then water will also try to escape as much as possible, to escape from the bottom or within the dam itself. So you can imagine if there's something permeable, that would be kind of a weak point. Then we're saying site should be such that tributaries carrying very high content of silt do not lead to the reservoir uh, developed by the dam. What we are saying, this is the ideal scenario, but very difficult actually, because in the recent years, one of the problems with our dams is what is called siltation. The rivers bring a lot of silty materials and the deposit, because you can, once you put up your dam, and then these rivers bring up silt, and if the height, like I've said, I think previously, I have to draw again. So if this is your dam, and the initial height was, I don't know, 200, I think, let's assume, then the river brings and put seals here, deposit seals there, and maybe up to 10 or 30 meters or 20. Then the height is no longer 200, you have 180. And this is a problem will affect, this problem will affect the, of course, the amount of water impounded, which will affect if it's a hydroelectric dam, and so will affect the so siltation is one problem. So we are saying that the site should be the tributaries that bring silt should not lead directly to the reservoir, but it's very difficult to ensure that this happens, because basically the river maybe has traveled uphill of necessity, or it will carry some silt or some material that of course will be deposited in the dam. Obviously, when we are constructing the dam as well, we take care of all these things. There are some at the bottom, at the, I don't know how many dams you've visited. Usually, there are some unique structures provided at the tunnel, at the at the at within the dam, unique structures with controlled diameters, such that if silt, this is your height of water. If silts deposit here, then there is a pumping mechanism, because hopefully the silt is not deposited, is not hardened. Then there's a mechanism that you can flush the silt out and leave the dam uh, um, to be free and resume its uh, height of impounding water. However, this is only if there is controlled siltation. Otherwise, if the siltation is uncontrolled, there is still a problem. In fact, currently there is a big problem, because upstream, there's deforestation, people are doing a lot of agriculture, and all these things lead to erosion. All the soil is going to lead into the river, and of course the river is going to carry them to the dam, and this is the biggest issue, why you hear that we don't have water in Nairobi. The dams that survive, that supply the water, uh, they deal with a lot of siltation, and because of the problems upstream. So the it actually, here we've talked about most of the factors, but because topography, here we've talked about even the geological, the foundation factor. We talk about permeability. We talked about the availability of the materials. But here we are trying to separate the issues. So some of these issues might overlap, but please do not confuse that the issues here, some of them are individual issues, not under topography. All these might help to explain topography, but each of those, if you talk about topography, talk about foundation or geological factor, even the availability of space to build a spillway is a separate factor. But you can see that topography will affect, will influence, or will decide, will help us see, will influence whether we have enough space to put a spillway. Number two, topography will affect the fact that because they are heavy machinery, how do you access the site? So the terrain as well. So these factors are intertwined. Again, a hilly area or a mountainous area, most likely they are rocks. We don't know whether they are permeable or not, but you can see all these factors are intertwined. So we continue to elucidate down here that geological and foundation conditions, which we have talked about in topography as well, but these are different and separate factors. So this should be thoroughly surveyed because the foundations have to carry the weight of the dam. That's the first thing. Various kinds of foundation generally are encountered as solid rock found. So if we find rock, I think this is the best thing we can ever get. Good rock of good strength, not just any rock, and granite, and continuous as well. Because if there are lines of weaknesses, then that is a potential disaster. So in the you will see when we are talking about the site investigations, you will do a thorough scan of the area and do a test pit. And of course, it's a very expensive affair that requires experience, because again, if you spend too much and find and so first, this is an area where experience is important, and also because it's an expensive affair. And if you initiate dam construction and realize eventually that is not feasible in the process of construction, after you spend a lot of money, then many actually, in fact, in such projects like dams or even tunnels, companies have gone broke because of this. If they get they are improperly advised. So you need, for example, to map the geological condition of the dam, the foundation. You have to scan and know exactly are there faults, or is the place prone to earthquake, exactly how many faults, and you have to take a measure to seal each and every, if there are faults or no. I mean, actually, the areas of natural phenomena like earthquake or faults need to be avoided altogether unless you have no other choice. Now, when there are lines of weaknesses like fault lines and all those have to be sealed and mapped properly and be controlled, because you can imagine when you have a height of what of 240, there's so much pressure that if there's any form of weakness, then that's a potential disaster. And normally, there's upstream, that's the source of water, that's your dam, and there are people living downstream. So it can be worse if there is a city or people living downstream. That would be a big issue. So then we are saying the bearing power or bearing capacity, almost of every kind of dam can be built on such foundation. So solid rock, especially continuous, there are no fault lines or no cracks, and granite is the strongest rock we know. So that if you find that, you're very lucky, because then you can build any kind of dam on it, and there are no limitations, because uh, uh, of course you have to design, but it's a very good foundation, I should say. And the dam can be carried, all sorts of dams. And then gravel foundations are suitable for earth and rock fill dams. And then silt and fine sand foundations suggest construction of earth dams or very low gravity dams. Yeah. So the best foundation you can find is solid rock. If you find gravel and silt and fine sand, then these are the options you have. Okay, so so those decide which kind of dam and also the position uh, of the dam. Clay foundations are likely to cause enormous settlement of the dam. Construction of gravity dams or rock-filled dams are not suitable on such foundations. Earthen dams after special treatments can be built. Okay, that should be self-explanatory because I'm sure now you've done enough soil mechanics. If this is why one of the requirements for this course is soil mechanics, to understand that clay foundations are troublesome and have a lot of issues, settlement being one of them, of course, and unless the even for over consolidated, the clay is basically troublesome. That's the point. So if you find it that you have to use it as a foundation material, then you need to uh, make special consideration. The knowledge or the skills of which come from uh, soil mechanics, which I believe you have covered sufficiently in the previous courses. Now, availability of materials, again, I've said if you're doing an earth dam, you'll need a lot of borrow materials. The borrow pit materials, cause you because this is that's your dam, and of course you know now the pressure would be increasing here. So if the height was 242, let's say 240, okay, let's use some round figure. That would be 9.8. The pressure there would be 9.8 times 240. Okay, the pressure there, and you can do that calculation and also check the force. The force would be a third of this, a third of the height. So 240 over 3, and the force there would be a half times this value here. Okay, let's use 10, so that's 2400 times the height is 240. So those are enormous forces. This is already 2000. This is 1200 times. These are enormous forces. This is a point. So you need to design this properly. And typically, the material in this part is this is an earth dam. Actually, okay. Uh, let's talk about the theory first. No, I think earth dam cannot reach that height. But anyway, let's because of the enormous stresses here, this part has to have material of good shear strength. Material of good shear strength. Shear strength. Good shear strength. Strength. That means the phi have to be high. The phi have to be high, most likely high. So here you can use rocks uh, or gravelly material of good shear strength, and but the problem with such material of good shear strength, they have high permeability, and then so water will try to escape, and that's why you always design a carefully selected filter here. Filter, okay, excuse me a minute. So we usually design a filter, and this filter is for example clay, because clay has low permeability. So even though water will try to escape for in this through this high permeability material, though they have good shear strength, They can resist the pressure of the soil. I mean the water. We need to stop because clay has low permeability, and this is carefully designed to make sure there is not so much seepage or water passing through. And again here, because of there is what is called escape velocity. Escape. Okay, there's something called escape velocity. There's something you call escape velocity because like I've said, it's difficult to actually prevent the water from escaping. So there will be some bits that will escape. So because of very high head, so when the water flows here, it will exit at uh, very high velocity, and that might tend to erode. So again, this part also needs material of good shear strength. So all that, if for example you are talking about an earth dam or concrete dam, then that material has to be available for the construction. So that also determines the choice or the site. So and then also the distance, the distances. If for example they are not available around, then the distances through which we will be able to find them. Then earthen dams are usually not provided for heights more than 30 meters for obvious reasons, because the pressure is so much and the earthen materials do not have beyond 30. The forces are quite enormous. That is not either not economical or safe to design earthen dams more than 30 meters. Now, for greater heights, we choose gravity or concrete dams are generally preferred. And of course, for this kind of dam, spillway is very important for the choice. Did I say, please also note that availability of spillways. Yeah, so another important factor is, which is not captured here, is the uh, another important factor not captured here is the availability of spillways. Availability of space. What is happening? Availability. Something is not happening, is not right. Uh, anyway, it's refusing to write. Something that's very important also is the availability of spillways uh, as a separate factor that influence the location of the dam. It's important because otherwise the dam, when it is full, it needs as a necessity, as a matter of necessity, a place through which excess water will flow away, and to ensure sustainability and the safety, long-term safety of the dam, excess water has to be able to flow through the spillway. Otherwise, if there is no spillway, the water may overtop the dam, and of course, it's water under very high pressure. If it erodes the dam, the main dam or the impounding structure, then of course people downstream are in danger. Now, spillways are special facilities guided properly. Even if the water escape, it is going to be routed back into the river and safely transported to the ocean, or somewhere that is safe, where it doesn't affect other people. So several factors. So first, I've said the height of the dam, availability of materials, availability of space to build spillways, the geological and foundation conditions, the topography. So those are very important factors to consider for the choice of the dam, and also to uh, the choice of the dam, and also the method of construction. I think we will end here unless there's a question.